Welcome to the video series on ABB AC500 PLCs and HMIs. On completion of this particular video, you will have an understanding of the integrated visualization feature of ABB AC500 controller. So the primary objective of this video is to present the fundamental steps pertaining to configuring the frequently used visualization objects and setting their dynamic properties through appropriate animation schemes for making a meaningful process plant or machine data monitoring and control. The other possible visualization functionalities like alarms, trends, histogram, etc., are also briefly discussed. Here we go. To make this video learning session a bit easier, we would take an example as this. That is, we have developed a controller program that needs to be tested off-site by simulating the I/O signals from the visualization screen, which is in a way some sort of a controller pre-commissioning exercise. This simply means, without even having the actual field hardware, like sensors and actuators, we are able to test the program completely in a laboratory environment. It is also possible to use the simulator function of code assist to mimic the CPU functionality itself. As such, we have implemented a simple motor start-stop control function in this example controller logic. The motor is started by pressing a normally open type start push button, and stopped by a normally closed type push button. The output of this logic drives the motor contactor, and there is a feedback from the motor to ensure that the motor is correctly operated in the field. If the motor contactor does not get energized in the field within a stipulated time, means the output logic will be made off to de-energize the motor. Therefore we have here 3 inputs and 1 output which would be simulated from the visualization screen. In order to create visualization screens, one need to click on the visualization tab in the code assist editor. So let's create a visualization POU using the add object function. One POU will have only one screen, and we could create as many SPOUs that we need in the same way. The start picture POU must have the name PLC_VISU, and the pictures or pages could be linked to this main screen for better navigation. Now we create a title for this screen using the rectangle object and place it on the desired position in the screen. Just by double-clicking on the object we are able to configure its various properties, both static and dynamic ones. Properties like color, text, position, visibility, security, etc. could be configured as needed with necessary actions as needed. In this way, we have also inserted a static background picture, already prepared to display the status of the motor running condition with color animation. Now we create 2 separate buttons to start and stop the motor. Buttons could easily be configured with some actions like initiating or triggering some events from the visualization screen, in effect changing some tag or data values in the controller. In this example the buttons are configured like a push button, meaning that pressing and depressing the button would send inverted Boolean data to the controller. When we deal with objects that have same property but different tag, we could make use of the simple copy-paste Windows function. This would also ensure an uniform look and feel of the identical objects. They could have the right text to reflect their action as a button name and could have color animations to indicate the current or next action status. We could also use static text to indicate the functionality of certain object and the outcome of certain actions. we create another rectangular object to indicate the error status of a motor, and label it appropriately for easy recognition. All objects need to be aligned properly to have an easy view and operating possibility while online with the controller. Now we are ready with a typical screen to test run our controller program, and at the same time the visualization functionality. We could now log in with the controller and able to operate the buttons and test our controller program, by enabling the simulation mode in the visualization screen. This way it would be possible to test a controller program before field commissioning with the help of code-assist visualization. We look forward to your viewing of more such videos from ABB, and would appreciate your feedbacks for further continuous development.
Thank you for attending this video. If you want to learn more about scale of AC500 controller, please use the following link. Or if you have an additional technical question, you can contact our helpline support. For general comments and questions about this video, don't hesitate to contact us.